Okay, we are now recording. So behave, Bob Barker. Okay, so today actually pretty easy lesson, honestly. There are a couple things that we're talking about today. Oops, don't look up here. Everybody close your eyes. Okay. There are a couple things that we're going to discuss that you've probably never seen or heard before, but then there's going to be some things that you have, okay? The main thing we're talking about today is functions, okay? But to kind of get us into functions, we have to start with this term called relations, all right? When we talk about in math, the relation would be between two values, okay? So relations in math is a set of all the ordered pairs that might exist for a certain group of numbers, or it could be, a variety of different things that we would see. So when we talk about a set of ordered pairs, there's different ways that we could actually distinguish them. One, you could see them in a table. Y'all seen tables before, right? Like a little chart. Sometimes they're vertical, sometimes they're horizontal. All right. Now, also, let's quickly discuss about, I think the key here is the ordered pairs. What is an ordered pair always made up of? An X and a Y. So when we think about a table that's vertical, where's the X always located? It's the first one. It's the one on the left. And of course, the range or the Y is always to the right. So X is on the left, Y is on the right. Okay? That's what our table would show. Sometimes those tables are horizontal. If the tables are horizontal, where will X be? On top, and the range or the Y will be on the bottom. Okay, so you're going to see tables. One that you're not as familiar with probably is you might see them on a mapping. If you don't know what a mapping looks like, turn your note page over and look at number 5 and 6. That's a mapping. Okay, probably my favorite one because they're just so easy to distinguish. But sometimes you'll see these relations organized as a mapping. Sometimes you're going to see them on a graph. All right? And then the last one, the one that we're going to discuss, is they can be expressed as an equation. Okay? So we're going to see these ordered pairs, these X and Y's, in a bunch of different ways. Tables, ordered pairs, mappings, equations, or on a graph. Okay? Now, when we talk specifically, and I kind of gave this one away already, when we talk specifically about the X values, there's another name that we use to indicate the X values, and that is the word domain. The domain. Does anybody know what the Y values are called? Domain and starts with R. Anybody? Range. Domain and range. Now I know that range is also used in another way in math, and that is if you have a single group of data, the range is the distance from the lowest value to the highest value. Y'all remember that? We're not talking about range from that perspective. We're talking about when we have a group of ordered pairs, the domain is a set of all the X values, and the range is the set of all the Y values. Okay? Now, sometimes we look at these groups of ordered pairs, and that's all they are. They're just distinct points. When they're distinct points, we call that group of data discrete. Discrete. But sometimes we're not just talking about the ordered pairs. We're talking about the lines that are created by a bunch of ordered pairs. And when we talk about the lines that are all connected because there's just so many ordered pairs, we actually call those continuous. Continuous. And because they're continuous, we have to name the domain and range differently. We'll get to that in a minute. Okay? Any questions with all those terms? So we're talking about ordered pairs. We're talking about X, domain, Y, range. We're talking about discrete versus continuous. And we probably won't say those words a ton. Now, a specific type of relation is called a function. And there are certain things that will keep some group of ordered pairs from being called a function. And it's described right there. Look, it says a relation in which each element of the domain is paired with exactly one element of the range. And I know that sometimes when I read that, it's like blah, 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 right? Like, you have no idea what that is saying. So I'm going to show you what I'm talking about, giving you a group of 4 ordered pairs. Okay, this one right here would be considered a function, okay? So here's this group of ordered pairs that are considered a function. 0, 1, -5, 2, 6, -3, and 5, +7. That group of ordered pairs is considered a function. Okay? Now, is that the only function we could ever come up with? No. It's just an example of a function. But here is an example of 4 ordered pairs, and there's something specific about this group of ordered pairs that causes it to not be a function. And I want you guys to try to see it. Here they are. We've got -7, 2. We've got 6, -1. We've got -3, +9. And we've got 6, +2. Does anybody recognize what is different about that group of ordered pairs that might follow along with what's said in that little definition above it that causes it to not be a function? What do you see, Whitney? There it is. Y'all see that 6 right there that's repeated? That is what causes this to not be a function. Let me explain. Look at the definition above. It's a relation in which each element of the what? What was domain again? X. So it's a relation where the X is paired with exactly one element of the range. Guys, what's the range? Y. A function, you can only have an X giving you one Y. If I ever have an X giving me multiple Y's, it can't be a function. And if you look at these ordered pairs, that 6 cannot give me -1 one time, and then that same 6 give me a +2 another time. That's what causes this to not be a function. X cannot be repeated. X cannot be repeated. If X is repeated, it's not a function. You got me? X cannot give me multiple Y's. X cannot be repeated. Now, not only can you see that with a group of ordered pairs, you can see that in a graph. Let me explain. This would be a great example of a function. What is that? It's a line. A line is a great graph representing a function. But let me draw you a graph that's not a function. A circle. I'm going to explain to you real quickly what we just talked about and why this is proof that it's not a function. Okay, look at this thing. I want to go to the X value, because I know you guys know ordered pairs, don't you? the x value of 2. Would y'all agree that the x value of 2 could possibly be about right there? Well, look at this example. From the x value 2, why is this not a function? Guys, x cannot give me multiple y's. X can't be repeated. Well, look at this graph. At this x value right there, can I go up to this graph? But can I also go down on that graph? So at that x value right there, it's giving me multiple what's?
Y's.
Giving me multiple y's. X is being repeated. Now, is that the only place? No, it doesn't matter though. If it happens one place, it cannot be a function. So, they developed this quick and easy little thing where you can take your pencil and you can check to see if a graph is representing a function or not. They call it a vertical line test. Look to the left of your paper. You see what it says? Vertical line test. A vertical line test will allow me to quickly check to see if a graph represents a function. Because look, guys, if I took my pencil and I ran it across here, what it's showing me is when I run it across from left to right, what am I going across? Which axis? The x-axis. So as I run this pencil vertically across the x-axis, if I'm ever hitting multiple points, it's showing me that at that x, you're hitting multiple points, and therefore cannot be a function. Vertical line test. A vertical line test determines whether or not a graph can be a function. What does a vertical line test tell me?
Whether or not a graph can be a function.
Whether or not a graph can be a function. Can you remember that?
No.
You can't? That's not hard, right? It's not hard. That's not a function. Okay? So, let's look at the different ways we can see these. Let's name our domain and our ranges, and then determine whether or not it's a function. So, first, we're just going to start with some ordered pairs. Okay? What's the domain of this group of ordered pairs? You have to think a lot for this. How do I name my domain? Just start spitting out your x values. There they are. Now, I personally like to put them in numerical order, but if you don't put them in numerical order, you think I'm going to mark them wrong? You think I'm going to come by your seat and smack you in the face? No, I'm not going to do that. Remember, being recorded. I don't do that. I don't slap people in the face.
You hit me yesterday.
What? It's trying to get me in trouble. You should have done better on your quiz. Alright, so my domain includes -1, 0, 4, and 6, right? Now I put them in order. They were already in order. Did you have to put them in order? No. Okay, so y'all help me out then. Tell me my range then. The range is my group of what? Y's. What is my y's?
-9.
-9. -5.
-2 and 3.
I would put -2, and then 3. You don't have to, but thank you for putting them in order. I like it. That's how I like to do it too. Now, last question. Is this one a function? Are any x values repeated? That's all you got to ask. Do any x values get repeated?
No.
Then is it a function?
Yes.
Yes. If x is not repeated, it is a function. If x is not is repeated, it's not a function. Okay? Not repeated, function. Repeated, not a function. Okay? So look at number 2. What's my domain?
-3, 5, 5, and 8.
-3. He said 5, 5, and 8. Do you have to put 5 twice? If you put 5 twice, am I going to mark it wrong? Am I going to come by and smack you in the face? No, I'm not, Vaughn. So I would only put it once because it's the same number. You don't have to put it twice. You can, and I promise I will not mark it wrong. And then how about my range?
-6, 0, 2, 4.
-6, 0, 2, and 4. And again, if you didn't put them in order like me and Vaughn here, that's fine. As long as those are your 4 numbers that you have written down. That's what I care about. Okay, big question. Is this one a function? This one is not a function. Why? Because 5 repeats. 5 cannot give me 2 one time and give me -6 another. That cannot be a function. You follow? Easy stuff. Now let's look at it from a table. And I don't have to do both of these, do I?
No.
So what's my domain?
-4, 0, 2, 7.
-4. Why is it doing this? It's getting all glitchy on me.
Probably operator error.
I wonder if it's almost out of battery. Oh, I see what it is. There we go. This little thing can come unscrewed somehow. All right, it's not operator error. I don't make mistakes. -4, 0, 2, and 7. And that's a joke. I've made a couple in my life. And then what about the range?
-8, -1, 3.
All right. And the last, the big question, is this a function?
No. Oh.
Uh-oh. We got a little disagreement? Yes?
Because it's not the X repeating so long.
There it is. This one is a function because exactly what Vaughn just said. X doesn't repeat. I don't care that Y repeats. That's fine. X can't give me multiple Y's. I could have 2 different X's give me the same Y all day long. I just can't have X giving me multiple Y's. So that one is why this one is a function. Number 4 is a function. And y'all can see your domain and range. Okay? All right, let's move on to the back. My favorite, the mappings. The reason this is my favorite is you don't even have to think. When they map it, they literally have your X's circled in one circle. Well, an oval, I guess. And then they have your ranges, your Y's, in one oval. And I'm almost positive I've never seen a mapping where they're not even put in order already. So my domain here is what, y'all?
-4, -2, 5.
And then my range?
0, 3, 7, 9.
Y'all look at this and think to yourself, how can number 2 be this easy? That's sometimes what I think. But it really is. Don't think that this is too easy. Okay? Sometimes math doesn't have to be hard. Now, last question. Is this one a function?
Yeah.
You sure?
It's not a function. No.
Why, Vaughn? What's happening that makes this not a function?
I don't even know, to be honest.
Okay, look. Right here, what is 5 telling you? What's happening from that 5? Can X give me multiple values of Y? No. In this case, if you looked at it, if I were to write these both as ordered pairs, Vaughn, those 2 ordered pairs would be 5, 7, and 5, 9. X can't give me multiple ordered pairs. Okay? So, not a function. You with me? Okay, so look at number 6. We don't have to name them. Let's just ask whether or not it's a function. Yes or no? Yes, it's a function. Okay, and look at why. The only thing that's repeated is the 7. The 7 is a what?
Y.
It's a Y. That's fine. Every one of those X values have one arrow going away from them. It's a function. Okay? Y'all with me on that? All right, let's move to the graph. Now, on number 7, if you struggle with this at all, I would recommend you just go write all the ordered pairs. But what I like to do is, for x, I just like to scroll across the x-axis and write all the values that I see a dot, either above or below it. So like, for example, if I start right here, isn't this the first place you see a point above it?
Yeah.
So what's that x value? What's that part of your domain? -3. And I like to go left to right because what will it automatically do for me? It'll put them in order for me. So the next point I see is right there, above that x value. What's that x value? 0. Let's keep scrolling from left to right here. There's a point below it. What's that x value? 2. And then finally, there's one more spot on the x-axis that has a point either above or below it, and that's what? All right, so there is my domain. You with me? How do I do my range like that? I just scroll up and down, right? So again, I'm going to start at the bottom. That way it's in order. The first place I see where I have a y value to the left or right of it is way down there at what y value? -5. Let's keep scrolling up. Here's the next place I see a point to the left. What's that point on the y-axis? -2. Here's the next one. What's that value on the y-axis? -1. And then here's the next one. What's that value on the y-axis? And then finally, right on the y-axis, what's that number? So there's the list of all my ranges. Okay, last question. Does this one pass the vertical line test? No, look, right here, right off the bat, right there, I'm hitting 2 points at the same time. It does not pass the vertical line test, therefore, not a function. Questions about that? Okay, we're about to change over. And instead of talking about discrete relations, we're moving into what we call what? What was the other one besides discrete? See, all the ones up to this point have been specific ordered pairs, have they not?
Continuous.
These are continuous. Here's what I mean. How many of you guys would like to name all of the x values that could be on this graph? Look, isn't that an ordered pair right there? Where this little dot is, y'all see that dot? Isn't that an ordered pair?
Yeah.
Isn't this right here an ordered pair? Isn't this right here an ordered pair?
Yes.
Isn't this right here an ordered pair?
Yes.
Isn't this right here an ordered pair? How far do y'all want me to go? Am I annoying you yet? Is this one right here an ordered pair? How about this one right here?
No.
How about this one right here? Y'all want to name all those ordered pairs? No. Okay? Because this is a continuous relation. You name these domain and ranges differently, thankfully, because if you tried to do that, it would just never end. You see what I'm saying? So we do it in one of two ways. One would be what we call an inequality. An inequality. Y'all remember what inequalities are? X is greater than or equal to 3, for example. Y'all remember this? X is greater than or equal to 3. That's an inequality. I like to use another method better. It's called interval. An interval is just two values. Where it came from, okay, the smallest value it could be, to where it's going, the biggest value it could be. So for domain, I would go, well, hey, how far does this thing go to the left? How far does this thing go to the right? And that would be my two values that I would name in that interval. For range, for y, I would say, hey, how far can it go down? And then I would say, well, how far can it go up? And those two values would be the interval for my range. You follow? Like for example, right here. Y'all remember this when y'all used to graph these like this? And right here at 3, you would do a closed circle, and then you would shade to the right. Y'all remember that? And that was because what was the smallest value it could have gotten to the left? 3. So it started at 3, but how far could it go to the right? Forever. What's the other word we call forever? Infinite or infinity, which we name with an infinity symbol. That is the interval notation for x is greater than or equal to 3. Okay? Because I'm recording this, let me just write it one more time. The inequality x is greater than or equal to 3 as an interval would be from 3 to infinity, for example. Now, let me help you name these using interval notation. Look right here, the domain. Remind me, please, what's the domain? X. Guys, how far will this thing go to the left? It'll go forever, won't it? So where is it coming from? What's the smallest value it could be? The smallest value it could be is negative infinity. It goes forever to the left. How far does it go to the right? So the biggest value it could be is positive infinity. So my domain, because it's continuous here, I would name it negative infinity to positive infinity. Now what about range? Will it ever stop going down? Nope. Will it ever stop going up? Nope. So it's the same. It comes from negative infinity down, and it goes towards positive infinity up. Negative infinity to positive infinity is my range as well. You follow? Now, is this a function? Does it pass the vertical line test? Absolutely it does. You never hit 2 points at once. This is a function. A line is almost always a function. There is one time a line is not a function, and we're going to look at it in a minute, okay? There's one time a line is not a function. Okay, let me show you this one. Y'all see the graph? What's the furthest it goes to the left? Will it go forever to the left? No, look. There's a clear barrier right here on the x-axis where it won't go past it. What is that value? It will not go past negative 4 to the left. That's as far to the left. That's the smallest value it could be. Now, how about to the right?
Infinite.
It goes forever to the right. So my interval for domain is from negative 4 to infinity. Do you understand? Okay, now, don't get confused. Look at the range. Look at your lines, guys. Will this thing ever stop going down?
No.
No. It goes down and to the right forever. So what's the smallest value on the y-axis it could be? Negative infinity. Now look at going up. Does it ever stop going up?
No.
So how far will it go up?
Infinity.
So my range is unlimited. Whoa. Is this one a function? Ooh. Is this a function?
No.
It is not a function. Look, do your vertical line. What happens right here, here, here?
They hit.
You're hitting multiple points. Not a function. Do y'all understand that? Do y'all understand that?
Yes.
Okay. All right. And the last one, until we grab our own, let's look right here. Domain. What's the furthest it gets on the left or to the left on the x-axis? Negative 2. What's the furthest it gets over here on the right side? Positive 5. So my domain is from -2 to +5. Y'all see that? Now remember what range is? Range is up and down. What's the lowest it gets on the y-axis? -2. And what's the highest it gets on the y-axis?
Oh.
+4. That sound cool when I say it like that?
Yeah, you slick too.
Yeah. J Riz. Wait.
W Riz?
Oh yeah.
Pressing J.
I'm trying, man. I'm just not cool, you know? Alright, so function or not a function? Definitely not a function. Okay. Do you have your calculator?
Yes.
Alright, get it out. We're gonna work through these pretty quickly. What time we got here? Oh, we're doing great then. Okay, grab your calculator. Now, I would always recommend that you do this in your calculator. Second plus 7, 1, 2. If you ever forget that combination, I always keep it on the top right corner of my board. What that does is it resets your calculator. So whoever had it before you, if they zoomed in on a graph or if they did anything to it, it's going to clean it right back up. It's real fast. Where do we go when we want to graph? We go to y equals. We go to y equals. That's where we're going to go when we want to graph. Y equals. Now let's type this first one in. That is not minus x squared, is it? What is that equation? It's negative x squared. So make sure you use your negative button, not minus. Negative x, here's squared, plus 3. Graph. Yours look like mine? Okay, look at it, guys. Will this thing ever stop going left? Doesn't it go down and to the left forever? Doesn't it go down and to the right forever? So, how far left will this thing go?
Infinite.
What is the furthest we can come from to the left? He just said infinite. What do we call to the left forever? Where's it coming from? Negative infinity. How far will it go to the right?
Infinity.
So my domain, y'all, is negative infinity to positive infinity on number 11. All right, now let's go back down and look at the range. How far down will this go?
Forever.
What's forever down?
Negative infinity.
Negative infinity. Now, will it go up forever?
No.
No, there is a clear spot where this graph just cannot go above. So my range is limited to what number above?
3.
So my range is from negative infinity to 3 bracket. Because it's a definitive stopping point. It's not approaching 3, it gets to 3. The reason infinity has a parenthesis is, do you ever reach infinity? No, you're always approaching it. Now, was that one a function? Look back at your graph. Was that a function? Yeah. Vertical line test works great on that. I never touch more than one point at a time. It never goes back on top of itself. So definitely a function. Let's move on to the next one, which is a line. Let's go back to y equals. Clear it off. We've got negative 5x minus 1. There's my line. Guys, will a line ever stop going left?
No.
Not in this case. So where's it coming from to the left?
Negative.
Will it ever stop going right?
No.
So where's it going to the right?
Positive.
Okay? I hope that you are not just, you don't know and letting Vaughn answer. I hope you do know. Okay, it's not hard. Don't overthink this. Okay, how about range? How far down does it go?
Infinity. Negative infinity.
Yes. How far up does it go?
Positive infinity.
Does this pass the vertical line test?
Yes.
So it is a function. In fact, a line is always a function except for one incident. And we're almost there. So there's number 12. Let's go to number 13. It's the last one we can graph. It's the last one we can actually go in here and type into y equals. But we're just typing in -7. Now I want you to push graph and recognize what is the graph that's being graphed. What do we call that? Horizontal line. A horizontal line. Okay, so here's my easy question. Domain. Does this thing ever stop going left?
No.
So where's it coming from?
Negative infinity.
Does it ever stop going right?
No.
So where's it going?
Infinity.
All right, now range is different though, isn't it? Does this thing ever stop going down?
It doesn't go down.
It doesn't go down. Does it ever stop going up?
It doesn't go up.
It doesn't go up. The range is simply one y value, and that one y value here is what? -7. That's it. You could just put -7 like we have. You could put y equals -7. Okay? But that is the difference between it and what we're about to do is your domain is unlimited, but your range, it's only one value because it doesn't go up or down. It stays right there at -7 all the time. Is this a function?
No.
You sure? Does it pass the vertical line test? Absolutely it does. So clearly, I'm to the last example. Here's number 13. Here's the answers. Now I want you guys to think. Why can't we graph number 14? It's x equals. We don't have an x equals graph. We have a y equals graph. So here's what I want you guys to logic through. If y equals a number is a horizontal line, what do you think x equals is?
A vertical line.
A vertical line. Guys, will a vertical line pass a vertical line test? It's the one time a line is not a, let me say it one more time.
Function, not a function.
Very good. It's the one time a line is not a function because a vertical line cannot pass the vertical line test. So it's not a function. So last thing, your domain. If it's a vertical line, does it go left? Does it go right? So your domain is simply the value that it is. And what is that x value? -1. But think about the range.
Negative infinity, infinity.
Yep, it goes down and up forever. So my range is infinite. Negative infinity to positive infinity. And that's the difference between the two. So that's the one time a line is not a function. Okay? The one time. All right, so your homework is going to be this worksheet coming. It's 8 problems. Okay? It's not 100. It's 8. And it's as easy as these examples we've been doing. So y'all should be able to knock it out pretty fast. I know that we only have like, what time did I say we get out? 20?
Yeah.
We only have like 4 minutes, which is not a lot. But we had a lot of stuff to look at. A lot of different ways that these graphs could have been portrayed. Yo, you may. So 1 through 8 is your homework tonight. So it's only the front side because there is no back side. Actually, there's a bonus question on the back that I've written in invisible ink. If you can figure it out and solve it, you'll get extra credit. You gonna try that problem, Pond?
Yeah.
You would. Actually, you probably would choose not to do the homework over doing that extra problem, huh? Yeah. Just ignore it.